Well, howdy there. It's Mr. Thompson with a video math lesson. We're going to talk about area right now. It's a measurement of two-dimensional shapes, right? It's kind of how much space they cover up, okay? That's one way to sort of think about what area is. The first thing we need to talk about with area is converting between units of area, okay? It's a lot like the units of length, but there's a little twist, okay? Because area is more than just one dimension, it's two dimensions. So we measure area in square units. Okay, square units. It's like measuring things by the number of squares that it takes up. So a square is sort of your most basic unit of area. So that's what we call units of area, square units. For example, kilometers squared, meters squared, centimeters squared, and millimeters squared. Okay, so it's the same as the units of length for the metric system. These are just your most common ones, except they are squared. Okay, hence they're called square units. So we want to be able to convert between one to the other. So we'll start by going this direction from the big units to the smaller ones. Okay, and just like with units of length, from each of these units to the next one down, we're going to multiply, right? So remember when we went from kilometers to meters, we multiplied by 1,000. But we're going here from kilometers squared to meters squared. Well, in 1 kilometer squared, that's like 1 kilometer by 1 kilometer. That's 1,000 meters by 1,000 meters, 1,000 times 1,000. So the easiest way to write that is 1,000 squared, right? So to go from kilometer squared to meter squared, we are going to multiply whatever number we have by 1,000 squared, okay, or 1,000 and then times another 1,000. And then from meters to centimeters, right, it's going to be 100 squared, right, because 1 meter squared, a square meter is 100 centimeters by 100 centimeters. So 100 times 100 is we'll just write it as 100 squared. It's easy. It's an easy way to write it. And then from centimeter squared to millimeter squared, we multiply by 10 squared. Okay? And then, as before, going back the other direction, we're just going to divide each time by the same numbers. Okay? Pretty easy. So we'll do this 5 meters squared this time, and we're going to put that in centimeters squared, millimeters squared, and kilometers squared. So to go from from meters squared to centimeters squared, we're going to multiply by 100 squared. So I'm just going to put the 5 there. The first time I multiply by 100, I'm going to add 2 zeros, and then I multiply by 100 again and put another 2 zeros. So I get a total of 4 zeros, which is 50,000. Okay? Then I'm going to take that 50,000, okay, and to get the millimeter squared, I'm going to multiply that by 10 squared. So we're going to multiply it by 10 once, and then again. All right? So 1 0 for each of those 10s. 10 squared, I add 2 more zeros. So that with that I get 5 million. You can put the commas in. 5 million millimeters squared. Right? It's 5 meters squared. It's a lot of millimeters. Now to go back to kilometers from meters, I have to divide by 1,000 squared. So I'm going to put my 5 there, and I'll divide by 1,000 once, right? And I go over 1, 2, 3. And then I'm going to divide by 1,000 again, another 1, 2, 3, right? And I'll put my decimal point there, okay? And I'll get rid of my little squigglies and put a 0 in front of the decimal point, and I get 0.000005 kilometers squared, okay? So, not too tricky. Now, let's talk about finding the area of different shapes. And there's lots of formulas, okay? Lots of different shapes, and each shape has its own formula to find the area, okay? So we're just going to go through a few of them here. The most common ones, the ones you're probably mostly familiar with already, are squares, rectangles, and triangles, okay? Most folks have probably seen these already. A square has 4 of the same size sides, same length at the side, and it also has 4 90-degree angles. And to find the area, it's just the length of one side squared. Okay, and this is a lot about why we call the units square units. It's just your most basic shape. With a rectangle, we have 4 90-degree angles, and opposite sides are equal. Okay, hence these little marks. We have a length and a width, and to find the area, we just do length times width. Okay. Here's a triangle with 3 sides. Doesn't matter whether they're the same length, or there's 2 the same length, or whatever. We just take the length of a base and multiply by the height and divide by 2. It's missing a little 1/2 here. I'll stick this in. Okay, 1/2 the base times the height. And now you can use any side as the base. Right? I could use this side as the base here if I wanted to, but then the height would have to be from that length, from that side, to the opposite point, okay, that distance, and that distance has to be at a right angle. Right? The height is always going to be perpendicular to the base. So this could be the base as well over here, and then the height would be sort of this distance from that side to this point here, perpendicular. So you just have to look at which lengths you have and which base the height is perpendicular to that you're given, or whichever one you want to measure, or however the scenario is. Okay, so squares, rectangles, and triangles, pretty simple, not too tricky. All right, here's some more though. All right, parallelogram, trapezium, also known as a trapezoid, rhombus, kite, and circle. Okay, so each of these shapes is a distinct type of shape, mostly quadrilaterals here, except of course the circle. And they each have their own formula for area. Okay, so let's start with the parallelogram. A parallelogram is a quadrilateral with 2 pairs of parallel sides. Okay, which square and rectangle actually both fit that description, as well as rhombus. But if you're just given the one length, okay, and a height, just like the height of a triangle, okay, where the height is perpendicular to the base you're using. So actually one of these sides could be used as the base, but the height would have to be perpendicular to it. All you have to do is multiply the base times the height for a parallelogram. Pretty easy, okay? And you could do that with a rhombus if you were given the height. And this formula is if you're given different things. Okay, trapezium or trapezoid. Right, we have 2 parallel sides, one set of parallel sides, and the other sides are not parallel. Okay, that's the definition of a trapezium or trapezoid. And you have bases of different lengths. You have this one base 1 here, and then base 2 here, different lengths. You're going to add those together, base 1 plus base 2, multiply by the height, which is the distance between the bases, and it's perpendicular to those bases, and then divide by 2. All right, that's the formula for trapezoid. A rhombus, if you don't have the height like a parallelogram, you could use this formula for a rhombus if you had the height, but sometimes you might be given these diagonal lengths. Okay, and that's what these symbols are looking at, the diagonal lengths. So if you have, we're calling them x and y here. If x is one diagonal and y is another, then you can just multiply them together and divide by 2, or multiply by 1/2, and you get the area. Okay, a kite is a bit of a funny shape, often referred to as a diamond. Rhombuses are also called diamonds sometimes, but they're 2 distinct shapes. A kite is a shape, a quadrilateral, 4 sides, with 2 pairs of adjacent and congruent sides. So these 2 sides are equal, that's why they have these 2 little lengths, and they're next to each other, right, adjacent. And these 2 sides are congruent, and they're next to each other. So that makes this a kite. Okay, again, this is the exact same formula as a rhombus. So you take the diagonals, if you're given the diagonals, and you multiply them and divide by 2, or multiply by 1/2, right? And that gives you the area. A circle, okay, is our sort of odd one out here. It's not a quadrilateral, or it's not a polygon, right? It's a circle. It's a very specific shape, and you only need one measurement to find the area. For a circle, you have the radius, okay, which is the distance from the center of the circle to the outside of the circle, to the circumference, to the circle itself. And another way to think about that is it's half the diameter, right? Half the distance across the circle. okay, is the radius, okay? And to find the area using the radius, you multiply by the radius by itself, or in other words, you square it, right? And then you multiply by pi, okay, which is approximately 3.14, right? Or on your calculator, there's usually a pi button or something like that. So there's area of several different kinds of shapes. I'll hopefully get some example videos up of these kinds of things, but not too tricky. You just find the numbers you need and plug them in. So good luck. See you next time.